Watch this. 9 out of 10 students quietly lose marks on literally the absolute simplest concepts in their IGCSE computer science exams. And it happens in exactly the same way every time. Honestly, it completely sabotages their final grade. Well, we're going to change that. Let's look at these mistakes before you actually make them in the exam hall. In this explainer, we're transforming those really common errors into a total masterclass level of understanding. We're going to break down exactly what the examiners are actually hunting for.
So let's kick things off with a classic cold open exam trap. Think about this. What actually happens when a computer tries to count past its memory limit? A massive number of students fall into the trap of assuming the computer just, magically adds an extra bit of space to handle the overflow. They kind of treat a digital system like a piece of paper where you can just squeeze an extra digit into the margin if you run out of room. But unfortunately, CPUs, they don't have margins. They just drop the data entirely.
Let's break down a step-by-step calculation. Say we're doing standard base 2 addition, 151 plus 107. If you follow the carry row all the way across to the left, you'll end up with a brand new 9th bit generated by that final addition. But here's the reality of the hardware. IGCS registers are usually fixed at 8 bits, which represents 1 single byte. So the result actually exceeds the register capacity. The CPU simply cannot store a 5th bit in a 4-bit space or a 9th bit in an 8-bit space. That extra bit literally just falls off the register. Gone. Actually, fun fact, a similar overflow error is exactly what caused a multi-million-dollar rocket to explode back in the 1990s. Wild, right? In your exam, you absolutely must state that this creates an overflow error. And the consequence? Well, it results in mathematical inaccuracies, data loss, and potentially disastrous software crashes.
All right, moving right along to Section 1, Network Architecture, and specifically, the client-server versus P2P trap. There is a really clear contrast between these two fundamental network architectures. First up, we have the client-server model. Think of this as a highly centralized system. The server is the absolute boss here. It holds the shared files, it runs the network operating system, and it processes requests on behalf of the clients. It even manages shared hardware resources, like network printers. The client computers? They're basically just the customers. They request access and consume those services. But we contrast this with peer-to-peer, or P2P networks. In P2P, 2 or more systems are connected point-to-point, or back-to-back. There's 0 central server dictating terms. Both systems reside at the exact same level of hierarchy. They're completely autonomous peers that just share resources directly with one another.
So the really crucial point here is understanding how these peers actually connect to perform tasks, which brings us to a pretty fantastic concept, the overlay network. Now, don't let that term intimidate you. An overlay network is quite literally just a network built on top of another network. In this specific context, the nodes are the applications running in the computers, and the edges connecting them are the transport-level connections. In P2P systems, end hosts are often temporarily linked together into an ad hoc overlay network just to perform very specific communication tasks. This is exactly what's happening when you use a P2P application for a massive file download, live media broadcasting, or even just instant messaging. The computers dynamically linked up, share the workload, and then disconnect the second the job is done.
Okay, Section 2, Data and Protocol Traps.
To completely avoid the trap of just memorizing meaningless acronyms, you'll want to use the 3-layer explanation method for protocols. Layer 1 is everyday language. Start by simply grasping the core purpose of the protocol, as if you're explaining it to a friend, but you definitely can't stop there. Layer 2 demands technical vocabulary. This is where you replace those general terms with precise subject vocabulary to accurately define the process. And finally, Layer 3 is the exam-ready response. This is where you actually shape that technical idea into a timed response that directly addresses the specific question demand. You have to bridge the gap between description, which is just identifying the device or protocol, and explanation, which is actually detailing how it works and exactly why it's used.
To absolutely guarantee you hit those marks, there's a 4-question self-check you should run through. Before you write out your final answer, quickly ask yourself, what is it? How is it used? Where is it used? And why is it used? Plus, you must apply this to the context provided. If the exam gives you a scenario about, say, a school, a bank, or a smart home, your explanation of the protocol absolutely must explicitly tie back to that exact scenario.
Moving into Section 3, the examiner's secret formula.
All right, here is your secret weapon. We call it the answer upgrade template. Whenever you're tackling a complex, high-mark question, follow this exact sequence. First, the definition. concisely define the concept. Second, the mechanism. Explain step by step how the process actually works. Third, the scenario example. Apply the mechanism directly to the nouns given in the question prompt. And finally, the advantage or consequence. State the clear benefit or the exact error that occurs if things go wrong. Seriously, if you structure your long-form answers using this 4-step template, you are practically handing the examiner the mark scheme on a silver platter.
Now, let's talk about precision. The absolute key here is mastering command words and constraints. Just remember this golden rule. 1 mark usually equals 1 distinct technical point. Never ever repeat the exact same idea using different words, hoping it's going to count twice, because it won't. You have to rigorously tailor your answers to the command words. If the question says state, they just want a concise fact. If it says describe, you need to outline the characteristics. But if it says explain or evaluate, that's when you need to dive deep into the how, the why, and apply it strictly to the scenario constraints they provided.
And that brings us to Section 4, the final IGCSE knowledge check. We have covered everything from overflowing bits to examiner templates today. So here is your final challenge. Can you apply that answer upgrade template to a smart home P2P scenario? Imagine an exam question asks you to evaluate the use of a peer-to-peer network for sharing security camera footage between devices in a smart home. I want you to literally pause right now and mentally draft a full marks answer. Define the P2P network, explain the mechanism of how those smart devices act as autonomous nodes, apply it to the scenario of streaming security video without a central server, and then state an advantage, something like reduced bottlenecking. Getting totally comfortable with this thought process is exactly how you jump up a grade boundary.
If this breakdown made the concepts click for you, you're already halfway to a top-tier grade. But ask yourself this, if a P2P network has no central server, how on earth do the devices actually know where to find each other in the first place? Think about that for a bit. We are going to reveal the answer when we tackle the hidden routing traps in our next explainer. Keep practicing, and we'll see you then.